Alright, so in this video I'm going to introduce how to graph sinusoidal functions, namely sine, cosine, using the 5 key points, okay, on this graph. So how do we do this? Alright, so let's graph y equals sine of x, okay. So we start here at 0, 0. By the time we get to pi over 2, we're up to 1. Okay. By the time we get to pi, we're back down to 0. So we go up, and then we go back down. And by the time we get to 3 pi over 2, we're back down to -1. And when we get all the way full circle, and what do I mean by full circle? Like if you think about it, really all we're doing on a unit circle is we're tracking what the y value is as we travel all the way through. Like right here, the y value is 0. By the time we get to pi angle of pi over 2, we get a y value of 1. By the time we get over here, we're back to 0. And then by the time we get down here to 3 pi over 2, we're down to -1. And then we work our way back to 2 pi, an angle of 2 pi gets us right back to 0. Okay, so that's what I mean by going full circle. All right, so maybe you made that connection, maybe you didn't, but if you didn't, now you've got it. All right, so this is our graph, and by the way, it continues forever as long as you want to go. We're just restricting it to 1 period, okay, so on 0 to 2 pi. Now, what is the key 5 points? Well, I think it might be obvious. It's 0, 0, okay, where we cross the x-axis, pi, comma, 0, 2 pi, comma, 0, those are obvious points, but also these peaks and troughs. So the peak here at pi over 2 comma 0, and the trough down here 3 pi over 2 comma 0 down here. All right, so you got your peaks and you got your valleys and then you got your x-intercepts. Those are the 5 critical values there. What about for the cosine? Y equal to the cosine of x on 0 to 2 pi. We're just going to do 1 period. Okay, so 1 to -1. So we start at 1 and we work our way down. Pi over 2 gets us down to pi over 2. And then at pi, 3 pi over 2 and 2 pi. Okay, 2 pi. All right, so by the time we get down to pi, we're down here. And then we work our way back up, just like this. So I'm going to go down. I'm going to come up, I'm going to stop right there, all right? So what are the critical values here? The critical values, those key points are 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, and then 2 pi, 1. Those are the 5 key points there. And what we're gonna do, all right, so kind of giving you like a guideline for what's gonna happen here. So the steps to graph sinusoidal functions, sine x, cosine x, of the form a sine omega x or a cosine omega x, okay? So if I have some amplitude and different period, all right, how we're gonna do this? What we're gonna do first, step 1, okay, step 1, what are you gonna do? You're gonna determine the amplitude, okay, which is equal to the absolute value of A, all right, and the period, which the period is equal to 2 pi divided by omega. Okay, 2 pi divided by omega, your period. Now, number 2, what you're going to do after that, see, when you multiply inside the argument by some coefficient here, it's changing our period, right? You know, if the coefficient in front was just a 1 like it is there with the sine x and the cosine x, my period would be 2 pi. But now the period is changing, okay? So what are we doing? Like between 0 and 2 pi here, we're cutting that interval into 4 equally spaced pieces. How do we do that? We take 1/4 of it, 1/2 of it, and 3/4 of it, okay? And so that's how we're getting those numbers. So we're going to do the same thing, but we're going to divide instead the interval, and that interval goes from 0 to 2 pi over omega. All right, if omega is 1, then it's 0 to 2 pi, like our example was up here, into 4 equal subintervals. Okay, subintervals. All right, so you know that's what we did here to find, you know, where our critical key points were located. Okay, so that was the game plan. All right, so we're going to do the same thing in step 2. Now step 3, what are we going to do? We're going to use the endpoints of these intervals, or these subintervals rather, of the same length. Okay, so we're going to use the endpoints of these subintervals to obtain the 5 key points on the graph. Okay, so just like we did up here when we figured out these key points, all right, I find the x values and then I plug in to get those y values. And once I have those, then all I have to do is follow the trace of the curve, okay? So basically connect the dots, all right? You wonder why you had to connect the dots when you were little? It was preparing you for trigonometry in pre-cal. The last step, you know, is to plot those points, plot the 5 key points, and draw sinusoidal graph. To obtain one cycle. Now remember, this only gets you one cycle. If you want to extend it out, all you have to do is do the same thing over and over and over. So if you graph your cycle, okay, all you've got to do is copy and paste it as many times as you want to until you get tired, right? And that continues your curve out forever and ever. All right, guys, next video we're going to show you these step-by-steps, how to use the 5 key points in graphing functions of this nature, sinusoidal with amplitudes A and periods 2 pi over omega. All right, guys.